Hello everybody, welcome into another lesson. So today we are starting polar coordinates. So here on the board I have the unit circle with the various angles marked. So it goes from 0/2 pi all the way back around to 2 pi. Or you could also go in the negative direction from 0 all the way back around to negative 2 pi. There's no right or wrong way to go. So up till now we've been dealing with rectangular, otherwise known as Cartesian coordinates. Now polar coordinates are another type of system that are used, especially in navigation for pilots, for navigators on the seas, for all kinds of other applications. They may not use this exactly, but it's based on that because you're often dealing with angles, especially when you're at sea. You're going 90 degrees north or 35 degrees west or what have you. Those are based on polar coordinates. Now, what's different about polar coordinates is that in rectangular you have an x and y axis. Well, in polar coordinates every single angle is treated as its own axis. So you actually have infinitely many axes on the polar coordinate system. That is something that's different. Now, coordinates in the polar system are given as r theta, r being the radius and then theta being the angle that you're referencing. R just tells you how far on that axis you're going. So you might see each of these circular marks here. So I have radius 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's just how far along the angle's axis I'm going. And in polar coordinates, we do have an equivalent to the origin at 0, 0 called the pole. In polar coordinates, the origin is called the pole. It would still be the coordinate 0, 0 even in polar coordinates. Now, when it comes to rectangular coordinates, there's really only one way to list a given point in the coordinate plane. With polar coordinates, there's infinitely many possibilities. So if you have a positive r, if your r is positive, you're just going to use, for your angle, you'll just use theta. So let's say, for example, I had 2 pi over 2, right? I'm going to go up 2, and then my angle will be pi over 2. You can also have a negative equivalent. Now, if you have a positive for your radius, that denotes only along the pi over 2 axis. You're only going positive. What about a negative? What happens if you have a negative value for your radius coordinate? Well, your angle is going to change. So let's say I had negative 2, 3 pi over 2. Well, this would be positive 2, 3 pi over 2 down here, but negative means I'm going backwards actually above the origin. So negative 2, 3 pi over 2 is the exact same thing as 2 pi over 2. If I have a negative r, I'm just going to take theta plus 180 degrees and I get the equivalent. Because pi over 2 plus 180, or pi over 2 plus pi rather, is 3 pi over 2. So in other words, r theta is the exact same thing as negative r theta plus pi. They're the same equivalent. And you can go from 0 to 2 pi, negative 2 pi to 0. You can go 4 pi, what have you. There's many different ways to list the exact same coordinate in the polar system. So let's just plot some points to start. We'll just take it easy, we'll plot some points, but we will also find alternate names for that same coordinate. So let's say we're being asked to plot 3, 5 pi over 6. So we're going to plot the point 3, 5 pi over 6. So let's see, here is 5 pi over 6 right along here. It's this line right here. That's my 3 pi over 6, okay? That's where I'm plotting. Now, that tells me my angle. That's a good place to start. And my radius, I just need to count 3 units. So this is 1, 2, 3. So here is my point 3 5 pi over 6 right there. There's 3 5 pi over 6. But I can also have a negative equivalent to this. If I wanted to do that, let's say I want to make my r negative. So we're going to take negative 3. If I wanted to have a negative r, that's fine. I just need to take that 5 pi over 6 and go ahead and add pi to that. Well, that's the same thing as 5 pi over 6 plus 6 pi over 6, which would give me 11 pi over 6. This is the exact same thing as negative 3 11 pi over 6. Because if I think about it, right, I go here to 11 pi over 6, which is found right there. So you always start at the origin. Now, 11 pi over 6, this would be going in the positive direction. Going in the negative direction is actually going back on to 5 pi over 6. So this would be negative 3 11 pi over 6. Now, we also know that sometimes your theta is going to be negative. You can have a negative equivalent to theta. So how do you find the negative angle? You just subtract 2 pi from your current angle, right? So I'm going to keep my r positive, but I want to find a negative angle equivalent for 5 pi over 6. So if I take 5 pi over 6 minus 2 pi, well, that's going to give me 5 pi over 6 minus 11 pi over 6, sorry, 12 pi over 6, excuse me. Well, that would give me negative 7 pi over 6. So you could also write this as 3 negative 7 pi over 6. And that makes sense. If you were starting here going in the negative direction, here's negative pi over 6, here's negative 5 pi over 6, here's negative 7 pi over 6. So at 3 negative 7 pi over 6, there is another way to write that same point. So these are all ways, these all are the exact same coordinate. Here's your original, here's a negative r version of that, and then here is a positive r negative theta version of that. So that is the same way you, and there are many other ways you could write this, but these are all several ways of writing the exact same coordinate. And we got more. Let's say I give you the point 2 3 pi over 4. So 2 3 pi over 4, that's your original polar coordinate. So let's find 3 pi over 4. That can be found right here in the second quadrant. Here's 3 pi over 4 right there. That's going to be this axis, the 3 pi over 4. But we also have to add pi to include the other axis. So if we take 3 pi over 4 plus pi, that's the exact same thing as 3 pi over 4 plus 4 pi over 4. So in that, we're actually going to include 7 pi over 4. So we'll draw all the way down through 7 pi over 4, which is right here. So we have that entire axis. Now, let's find two other points, one with a negative r and then one with a positive r, negative theta. So to find the negative r, we're of course going to take that 2 and make it negative. Now, whenever you have a negative r, well, here's 2 3 pi over 4. Why don't we plot that? Here's 2 3 pi over 4. Now, to make this, to work with this as a negative 2, I need to take my 3 pi over 4 and add pi. Well, we already did that. You get 7 pi over 4. So with a negative r but still a positive theta, adding pi, you would get this. It's the same thing as negative 2 7 pi over 4. This is the exact same thing as this. Now let's say this time I want to keep my r positive. So we'll keep a positive 2, but I want to find a negative theta equivalent. So if I take 3 pi over 4, and then I subtract 2 pi to find my negative angle equivalent, that's going to be 3 pi over 4 minus 8 pi over 4, which would give me negative 5 pi over 4. So the negative angle equivalent would be negative 5 pi over 4. So 2 3 pi over 4 is the exact same thing as 2 negative 5 pi over 4. All those are the exact same way of writing 2 3 pi over 4. Let's do one more of these. All right. Good one. So this time we have negative 3, negative 7 pi over 6. All right. So we have negative 3, negative 7 pi over 6. We're given a negative r and a negative theta. So what are we going to do? Well, let's find negative 7 pi over 6. Negative 7 pi over 6 would be in the second quadrant because you're starting here, you're working backwards, you're working clockwise. So that would be going in the negative direction. Negative 7 pi over 6 is right here. And we know we're going to have to go straight through to include the entire axis. So here's negative 7 pi over 6. But here's the problem. Your r is negative. So your r is negative, so you're going to start at the origin. You're actually going to go backwards 3 units along this axis. So 1, 2, 3. You're going to be down here actually below the origin on this axis. So your point would be right here. This is the same thing if you're keeping your theta negative. If you subtract another pi in this case, you would end up getting positive 3, negative 11 pi over 6. Actually, that'd be, no, you add pi, you would end up getting negative pi over 6, excuse me. So you got to add pi. I don't know why I was subtracting, but you end up here along negative pi over 6. So here's your negative pi over 6. The positive r version of that is 3 negative pi over 6 when you add pi. That's the exact same thing as the original, as negative 3 negative 7 pi over 6. Now, what if we want to find, this time we have a positive r, why don't we find a positive angle equivalent for negative pi over 6. So let's keep our r 3, but let's take that negative pi over 6, let's add 2 pi to it because we want to find a positive theta. Well, that would be the same thing as negative pi over 6 plus 12 pi over 6, which would put you at 11 pi over 6. So this is the exact same thing as 3 11 pi over 6. And there are many ways, again, that you can write this. There are many different ways you can write this, but you were originally given negative 3 negative 7 pi over 6. Well, negative 7 pi over 6 is right here, but since you're going in the negative direction, you're going to go that way, which would really end up giving you a positive 3 negative pi over 6 when you add pi. And then if we want to keep the r positive but find a positive theta equivalent, add 2 pi, you would get the coordinate 3 11 pi over 6. So those are all different ways of writing the exact same polar coordinate. You're not confined to just one way of writing it like you are in the rectangular system. So this is very good to know about adding pi, adding 2 pi, subtracting 2 pi, because you can get, and how that works with your radius, because you can get this exact same point expressed different ways. But you notice the common theme is your radius is going to stay the same number whether it's positive or negative. You get the same radius, just your angle might change based on that. But okay, so we've talked about just plotting. Now, you can actually convert between rectangular and polar coordinates. And we're going to talk about how to do that. So, let's talk about converting rectangular to polar. Well, what about a circle in general? Because we have a unit circle, we know in general that x squared plus y squared equals the radius squared, right? Well, the radius is always positive, so that means your radius is equal to the square root of x squared plus y squared. So that's how you're going to find your r. Okay, now what about the angle? So in rectangular coordinates you have, of course, an ordered pair x, y. Well, x traditionally is equal to the cosine, where y is equal to the sine. Ever since we introduced trig in the unit circle, x has always equaled the cosine of theta, y is always equal to sine of theta. So, how would you go about finding that angle, however? Well, if you take y over x, that equals the sine of theta over the cosine of theta. Well, what's sine over cosine? Well, the tangent of theta, sine over cosine just turns into tangent of theta. That equals y over x. So that means that theta is going to happen to equal the inverse tangent of y over x. So you can convert from rectangular into polar by taking the sum of the square of the x squared of the x and y coordinates, setting it equal to r squared. Then you just find r is the square root of x squared plus y squared based on the radius of a circle, the equation of a circle. And then to find your theta, you're going to take y divided by x and take the inverse tangent of those. That'll give you your theta. So let's go ahead here and let's convert some of these to polar coordinates. So let's say I'm going to give you the point 1, 1. So here's your rectangular coordinate. So the rectangular coordinate I'm giving you is 1, 1. All right. So there's 1, 1 in the rectangular system. So that's going to be in the first quadrant. Now, what holds true between the rectangular and the polar system is that you should end up in the same quadrant on both. That shouldn't change. It's just going to be what your ordered pair is called. But we have the point 1, 1, right? So x is 1, y is 1. Well, first thing you should do is find your radius. So your radius is always the square root of x squared plus y squared. Well, your x is 1, so take the square root of 1 squared plus 1 squared. That's going to equal the square root of 1 plus 1, which equals the square root of 2. So your radius equals the square root of 2. Now, the next thing we need to do is find our theta. So we've already stated that the tangent of theta equals our y over x. Well, 1 over 1 is just 1. So theta is going to equal the inverse tangent of 1. Well, what angle gives you a tangent of 1? That's going to be based on a 45, 45, 90 right triangle, right? Or a pi over 4 angle. Now, where is the tangent positive, however? The tangent's not only positive in the first quadrant, it's positive in the third quadrant as well, isn't it? But your rectangular coordinate was given in the first quadrant. That means you need to find the first quadrant equivalent for the inverse tangent for this angle. So the angle, in this case, we're only concerned with pi over 4 because we want to end up in the first quadrant. So theta equals pi over 4. So we have our r, we have our theta. So we can now put this together to get our polar coordinate of r theta. R is the square root of 2. Theta is pi over 4. So the polar form of 1, 1 is going to be the square root of 2 pi over 4. So here is pi over 4 right here. Let's plot the square root of 2. I know that's going to be just a bit more than 1, so that's going to be about right there. There is the square root of 2 pi over 4. And if you notice, we end up in the first quadrant even in the polar system, as we should, based on the rectangular. Your quadrant should not change between the two. It's just going to be what your coordinate's called. So there's the square root of 2 pi over 4 plotted in the polar system, and that's how you convert. We'll do a couple more examples of this, and then, believe it or not, we can work backwards. We can absolutely work backwards. So let's give you... Alright, so why don't we actually give you negative 7, 0? So you have the rectangular coordinate negative 7, 0. Well, where is that? If we pretend this is a rectangular system, you're going to be right along the x-axis to the left of the origin, aren't you? Okay, so let's find our r first. R is going to equal that square root of negative 7 squared plus 0 squared, which is going to end up giving you the square root of 49, which would just be 7. So your radius is 7. Whoops. So the radius is 7. Now what about your theta? So if you take the tangent of theta set it equal to 0 over negative 7, well, you would just get 0. The tangent of theta equals 0. What angle gives you a tangent of 0? Now be careful, because we're to the left of the origin along the x-axis. We know the tangent at 0 radians is 0, but same with the tangent of pi. Pi is left of the pole, so really in this case, theta is actually going to equal pi, because you want to be in the same position to the left of the pole, even in the polar system. So now we can find the polar equivalent. We have a radius of 7 we've already determined. That's not going to change, but your theta is going to be pi. So let's find 7. So here's 1, 2, 3, 4, 5, 6, 7. So I'm going to be all the way right here at pi. There's my pi. So I'm going to be right here at 7 pi. That is the equivalent, and you notice I'm to the left of the pole like I was in the rectangular system. So that is the polar equivalent to negative 7, 0 is going to be 7 pi. Now, what about 0, negative 5? Let's say I give you the rectangular coordinate of 0, negative 5. So that rides, our x-coordinate would be 0. That rides along the y-axis going down. Let's just pretend this is the normal y-axis. You would be down 5 units below the origin on the y-axis. You'd be riding right along the y-axis. So the angle we find should be the same equivalent in the polar system. Well, first let's find the radius. So the radius is going to equal the square root of 0 squared plus that negative 5 squared. Well, 0, 0, that's just going to give you the square root of 25, which means you have a radius of 5. So the radius we found to be 5. Now, what about your angle? So you're going to have the tangent of theta equals negative 5 over 0. And you're going to say, well, that's undefined. We can't do anything with it. Well, yeah, that's true, but even having an undefined tangent does give us something to go on. Where is the tangent of theta undefined? It's definitely undefined at pi over 2 and 3 pi over 2, isn't it? Okay, so what is normally the tangent of pi over 2? Well, I mean, what's normally the coordinate of pi over 2 in the rectangular system? Well, your x-coordinate's normally 0, your y-coordinate's normally positive 1. Now, at 3 pi over 2, your x-coordinate's normally 0, your y-coordinate's normally negative 1. So we need to figure out the angle that makes a negative undefined value. Well, that's going to be 3 pi over 2. So in this case, theta is going to be 3 pi over 2. We want to end up along the negative y-axis along the negative y-axis. We want to end up in a similar spot in the polar system. Now that we have our r and our theta, the polar equivalent is going to be that r of 5. So we have 5. The theta is going to be 3 pi over 2. So let's find 5 units now. Let's plot that point. So 1, 2, 3, 4, 5. So we'll be right here. That is the point 5, 3 pi over 2. And you notice you're down in the same spot as you would be rectangular along the negative y-axis. So the polar equivalent is going to be 5, 3 pi over 2. All right, one more of these, then we're going to work backwards. So let's see here. Let's say I give you the rectangular coordinate -3, -3. So -3, -3 in the rectangular system, well, that would put you in the third quadrant, wouldn't it? So that should give you a clue that your theta should be in the third quadrant in the polar system. So keep that in mind. So first, let's find the radius. The radius equals the square root of that -3 squared plus that -3 squared, which would equal the square root of 9 plus 9, which equals the square root of 18. Well, the square root of 18 simplifies into the square root of 9 times 2, which would be 3 times the square root of 2. So we have a radius of 3 times the square root of 2. Alright, now what about the theta? So we can say the tangent of theta equals our y of -3 divided by our x of -3, which would just simplify into 1. So we have a tangent of theta being +1. Now this is where I said bear in mind we should end up in the third quadrant in the polar system, because the tangent of theta is not only positive in the first quadrant, it's also positive in the third quadrant. So you would get a tangent of theta being 1, of course, at pi/4, but the third quadrant equivalent is 5π/4. So your theta is going to actually equal 5π/4. So here is 5π/4. Let me fill that axis in a bit. Alright, so there's 5π/4. So now we have the polar equivalent. So the radius, that r, is determined to be 3 times the square root of 2. My theta is 5π/4. So the polar equivalent to -3, -3 is 3 square root of 2, 5π/4. Well, that's going to be a bit greater than 3 along this axis. So here is roughly the point 3 square root of 2, 5π/4. And you notice that puts us in the third quadrant, even in the polar system. Alright, so we've converted from rectangular to polar. Now we can actually work backwards. We can convert from polar to rectangular. And it's actually not as bad as you think. In a way, it's easier. So let's say you're given the point 4. Let's do actually no, let's introduce it first. So if you have a polar coordinate, of course you're going to be given r theta, right? You're definitely given r theta. Well, what's nice is to convert to rectangular, polar to rectangular is actually pretty easy. So you have r theta in polar. Well, x is just going to be r times the cosine of theta. Y is just going to be r times that sine of theta. That's all that is. That's literally all it is. That's how you're going to convert from polar into rectangular. You just take your radius times the cosine of theta to get your x, and then take the radius times the sine of theta to get your y. So actually this is easier than what we just did. But what holds true like before when we were converting from rectangular to polar is you may be in one quadrant in the polar, you should end up in that same quadrant in the rectangular. So let's start there. So we're given a polar coordinate of we're going to have 4 negative pi over 3. That's our polar coordinate. So in fact, why don't we plot that? We know negative pi over 3 is going this way. So here is my negative pi over 3. That puts me in the 4th quadrant, doesn't it? So 1, 2, 3, 4. Here's my 4 negative pi over 3. I should end up in the 4th quadrant. So r is the first coordinate of my polar, so r equals 4. My theta equals negative pi over 3. So that means that x should equal r times the cosine of theta, or 4 times the cosine of negative pi over 3. Well, what's nice about cosine is we can use even and odd identities for cosine and sine. Cosine's an even function, so this would be the exact same thing as 4 times the cosine of positive pi over 3. Now, what is the cosine of pi over 3? Well, that's just going to be 1/2, so you get 4 times 1/2. That means your x-coordinate is going to be 2. So you end up having an x-coordinate of 2. Now, what about your y? So to find your y, that again equals r sine of theta, so that would be 4 times the sine of negative pi over 3. Well, sine's an odd function, so that's going to turn into negative 4 times the sine of pi over 3. What's the sine of pi over 3? That's the square root of 3 over 2, so you would end up getting negative 4 times the square root of 3 over 2. 2 cancels out with a 4, you should end up getting negative 2 times the square root of 3. So we found x to be 2, y to be negative 2 square root of 3, so the rectangular coordinate is going to be then x is 2, y is negative 2 times the square root of 3. So I'll get the coordinate 2, negative 2 times the square root of 3. And if we look, that would actually put me in the 4th quadrant, as it did with the polar system. You should get the same quadrant in both systems. You're just going to have it called something entirely different in the rectangular system. Let's do a few more of these. Alright, we are given 2 7 pi over 6. So we have the polar coordinate 2 7 pi over 6. So here's my 7 pi over 6. And the radius is 2, so I'm going right here. Here's 2 7 pi over 6. That puts me in the 3rd quadrant in my polar system, which means I should get something in the 3rd quadrant in my rectangular system. Well, let's establish some information based on this polar coordinate. My r is 2. My theta is 7 pi over 6. So what I have to do now, I know x equals r cosine of theta, so that would be 2 times the cosine of 7 pi over 6. Well, that's in the 3rd quadrant. 7 pi over 6 is the same as a pi over 6 angle in the 3rd quadrant. So that would be a negative value I would get. The cosine of pi over 6 is normally square root of 3 over 2, but since it's going to be in the 3rd quadrant, you would get 2 times negative square root of 3 over 2. Or you would just get an x value of negative square root of 3. So I get an x value of negative square root of 3. Now let's find my y. So y, again, this time it's r sine of theta, so my r is 2 times the sine of 7 pi over 6. Now, what's the sine of pi over 6? That's normally 1/2, but since we're in the third quadrant, that'll be negative 1/2. So this would be 2 times negative 1/2. Well, that would just give me negative 1. So now I got my x and y coordinates. So my rectangular coordinate would end up being negative square root of 3, negative 1. And that would definitely put me in the third quadrant, even in the rectangular system. So there is my rectangular equivalent to 2 7 pi over 6. All right, let's do one more, then we'll be done with the lesson. Okay. We have 0, 5 pi over 4. So we are at 0, 5 pi over 4 for our polar coordinate. Well, let's find 5 pi over 4. That's going to be right here. Zero 5 pi over 4. Well, remember how I said that each angle is considered its own axis in the polar system when I stated that in the beginning of the lesson? Well, so we're along the 5 pi over 4 axis, but we're moving 0 units on it. That's actually going to put me right at the origin, or in this case, in the polar system, that puts me at the pole. We should get the coordinate 0, 0, or the origin in the rectangular system, but let's work through it anyway. We know the r is 0, my radius is 0, my theta is 5 pi over 4. We're not going to have to do too much work on this one because x always equals r times the cosine of theta, so that would end up being 0 cosine of 5 pi over 4. Well, what do we know? 0 times anything is 0, so x is going to equal 0. Now y equals r sine of theta, so that would be 0 sine of 5 pi over 4. And of course we know that 0 times anything is 0. So in the rectangular coordinate system, now that we have our x and y coordinates, you'll get the coordinates 0, 0. And that's exactly what you would get, is the origin. So this actually introduces a nice shortcut too when we're working in the polar system. If your radius is 0, it does not matter what your angle is. This will be true for any angle. If your r coordinate's 0 for your radius, you're going to be right at the pole. So that can save you a lot of grief of knowing where to plot, because if you have a 0 on your r coordinate, it's a done deal. You're at the pole. Alright, so that's it for this lesson. Next lesson, we're going to convert equations between rectangular to polar equations and polar to rectangular equations. Then the lesson after that will get more exciting when we actually graph in polar coordinates. When we graph polar equations, you can get some really neat stuff when you graph in the polar system that you couldn't get in the rectangular. And you're going to see just how cool some of this really is. So I hope everybody has a great day. Take care.